Okay, we have a tangent line problem again. We have a circle, and the tangent line has a length of 32, and it's a circle with radius 24. If radius is 24, this portion from the center up to here is also 24, and from here to here is x. And you know that when you have a tangent line with the radius of a circle, it's always 90 degrees. Well, so we have a right triangle, meaning we could use Pythagorean theorem to find what x is. So we have 24 square, that's one leg, plus 30, another leg, 32 square, must equal to hypotenuse, it's 24 plus x, the whole thing square. Remember, hypotenuse, this one right there, is the always opposite length of the 90 degrees. That's always the side that's facing 90 degrees. And it should be the longest side in a right triangle. Okay, so we have our equation. So all we got to do is calculate it. So 24 squared plus 32 squared will equal to 1600. So that's 1600 is equal to 24 plus x, the whole thing square. I mean, I could FOIL this out and then do it, but it's much simpler if we do square root to get rid of that power 2. So square root of 1600 is 40. So 40 is going to equal to 24 plus x, where x is now equal to, subtract 24, so it's 16. So it's x is 16 in this case. Okay, let's do another problem. We have a circle with 15 and a tangent line, which is x. And you know, tangent and radius, it's 90 here. So radius is 15, so that's also 15 from here to there. And from here to here, it's 17. So we have another right triangle where x squared plus another leg, 15x, is now equal to 17 plus 15, the whole thing squared, since that's the hypotenuse there. Okay, so it's x squared plus 225, that's 15 squared, is 17 plus 15 will give us 32, and then square it. It's 1024. And then x squared is just subtract 225, so minus 225. It's 799. And all you got to do is square root that. So it's 28 point, let's see, 3. Let's round it up like that. So x is 28.3. There you go. Okay, in this case, it's radius that's x, meaning from here to here is another x. And then we have a 90 degree here. Okay, so one leg, which is 12.6 square, plus x is 2x, 2x the whole thing square. It's not just x square. 2x the whole thing square is now equal to hypotenuse, which is 21, the whole thing square. Okay, so we have 12.6 squared, that's 158.76, and then 21 squared, it's 441 on the right side here. And then 2x squared is, it's 4x squared, not 2x squared, because it's 2x times 2x. So we have 4x squared is now equal to 441 minus 158.76, 282.24, and then I'm just gonna solve for x. 282.24 divided by 4, and then we square root that. It's 8.4. So x is 8.4. Okay, here we have a circle with radius 12, and we have ED as a tangent, and CD is also tangent. A point outside a circle and all these tangent lines, they're equal to each other. So this length and that length are equal. So we could set them equal to each other. So we have 13x minus 16 is equal to 4x plus 11. Again, we're trying to find FD here, which could be the hypotenuse of these two triangles, right triangles. Okay, so we set 13x minus 16 and 4x plus 11 equal to each other. So let's bring 4x to the left side by minusing it. So that will be 9x is equal to, now add 16 on both sides. That's let's see, 27, and then divided by 9. Okay, so x is 3. Now, since x is 3, we could plug it in and find either ED or CD. Doesn't really matter because they're going to be equal to each other. So I'm just going to write or draw a triangle FED, which is a right triangle. Okay, so this is FED. I'm going to draw it separately. And then by plugging 3 in, 3 times 4, 12. So 12 plus 11, it's 23. So ED is 23, and FE is radius, which is 12, and we have a right angle here. And we're trying to find FD, so I'm going to call that X right now. Oh, let's not call it X. Let's call it, I don't know. Let's call it FD. Okay, that length. So we have 12 square plus 23 square is now equal to FD square. Let's see. So we have 12 square plus 23 square. That's 673. So 673 is FD squared, but I could square root that to find what FD is. So FD is square root of this. So it's 25.9. It's approximately 25.9.